Muito boa noite a todos. Meu nome é Natália Correia e em nome da diretoria da IGS Brasil, dou as boas-vindas a todos vocês para mais um webinar transmitido ao vivo pelo canal Geotecnia Brasil, a quem agradecemos já pela parceria. Hoje vamos abordar um tema cada vez mais relevante e presente nas discussões do nosso setor, que é a sustentabilidade em obras de engenharia geotécnica. E temos a honra de receber um convidado muito especial, o Sr. Boyd Ramsey, um profissional com mais de 30 anos de experiência na área de geossintéticos e uma verdadeira referência mundial quando falamos em sustentabilidade aplicada em engenharia. Este webinar vai ser conduzido em inglês e contará com a mediação do engenheiro Vitor Pimentel, membro ativo do Comitê de Sustentabilidade da IGS Internacional, ex-presidente da IGS Brasil, e um colega com quem tive o prazer de compartilhar 8 anos de trabalho na diretoria. So, on behalf of IGS Brazil, thank you very much, Boyd, for accepting this invitation. It's a real pleasure to have you with us tonight. Vitor,
well, thank you. I'm happy to be here.
Ok, boa noite, pessoal, boa noite a todos. É uma grande alegria, mais uma vez, estar presente no webinar da IGS Brasil, em parceria com o canal Geotecnia Brasil. Agradeço muito o convite mais uma vez, considerar essa minha presença como mediador com Boyd Ramsey, que é uma pessoa de uma referência enorme no nosso setor mundialmente, né? E, Natália, pessoalmente agradeço a sua introdução. Grande prazer também ter passado esses 8 anos com você trabalhando em prol da associação. E estamos aqui para mais um. Então, gostaria de fazer uma apresentação breve aqui, né, do Boyd, que é um amigo, né, com quem tive o prazer de trabalhar no Conselho da IGS Internacional por 8 anos. O Boyd Ramsey é líder no setor de geossintéticos, como disse, mundialmente, nas aplicações de contenção ambiental e descarte de resíduos. Ele tem atuação de mais de 30 anos nesse setor e tem uma trajetória longa, né, como ex-funcionário da GSE, que é uma das empresas referência no mercado mundial. Ao longo de sua carreira, esteve diretamente envolvido na indústria global de geossintéticos, né, geomembranas, GCLs, né, esses produtos que compõem sistemas drenantes e de filtração. Atuou por mais de uma década no Conselho de Administração do Geosynthetics Institute, incluindo um mandato como presidente do conselho deste instituto. Em 96, foi um dos membros do grupo que desenvolveu a tão utilizada e falada GM13, né, das geomembranas. Então, ele fez parte desse comitê que criou a GM13, né, que se tornou e ainda é a especificação global mais utilizada para barreiras geossintéticas, né. Ele é membro do Comitê Técnico de Barreira, dos Sistemas de Barreira da Sociedade Internacional de Geossintéticos, a IGS, né, desde a sua criação em 2010 até o presente data. Em suas funções, né, quando atuava no mercado na GSE, ele aconselhou e auxiliou o projeto e na seleção de sistemas de contenção em várias das maiores cidades do mundo, incluindo a cidade de Nova York, na instalação de Fresh Kills, em Hong Kong, na instalação de NENT, que é uma obra, para quem não conhece, assim, é uma obra realmente faraônica, e em outros aterros sanitários regionais, além de centenas de outros locais de descarte municipal nos Estados Unidos e em todo o mundo. Além disso, ele esteve envolvido no descarte de resíduos perigosos em locais dos Estados Unidos, como do superfundo de Savannah River, em parceria com o Departamento de Energia dos Estados Unidos, em instalações de descarte nos laboratórios nacionais de Oak Ridge e Lawrence Livermore, entre outros locais. Atualmente, ele é secretário e tesoureiro da IGS, da Fundação IGS, né, que é uma fundação criada para fomentar as atividades de educação da IGS Internacional e seus associados. Seus cargos anteriores na Sociedade Internacional de Geossintéticos incluem 2 mandatos de 4 anos como eleito para o Conselho da IGS e 6 anos como presidente do Comitê Técnico de Barreiras do IGS. Atualmente, ele é co-presidente do Comitê de Sustentabilidade da IGS, que é o tema de hoje, e ele é ex-presidente da Associação de Materiais Geossintéticos, a principal organização do setor para o avanço do uso geossintético nos Estados Unidos e mercados globais. So, Boyd, I just made your very brief presentation. I know that your experience goes beyond all that.
That was the long version, Victor.
And I have to believe, and you have to believe me that I have spoken about good things about you. So thank you so much, Boyd, for being here, for giving us the opportunity of hearing to your opinions on this very important matter that is being discussed all around the world with several technologies, construction technologies, including ours, the geosynthetics. So it will be a great opportunity for all of us to have this chance of hearing what you have to say on this. And after your presentation, if you give us a chance to make some questions and some Q&As, it will be very, very nice.
Thank you. Happy to do Q&A too.
Pessoal, então vou passar a palavra para ele. A todos que quiserem fazer alguma pergunta, pode lançar a pergunta nos comentários, tá? Eu vou depois voltar, né, depois da apresentação, e a gente vai organizar uma sessão aí de perguntas e respostas de mais ou menos 20 minutos, 30 minutos, ok? Fiquem todos à vontade. Boyd, thank you so much. Have a great presentation.
Okay, very good. I will share my screen here. And we will, oh, there we go. We've shared screen. So let me change over to my PowerPoint presentation. We can get my introductions going and we'll be all set. Thank you, Victor, for the kind introduction. First off, my apologies. I have no Portuguese. I can't present in Portuguese. So I've told Victor that if I say something that is confusing or that people don't understand, he's to interrupt. And if you don't understand something that I'm saying, please make a note in the chat, and Victor can stop and interrupt me, because if one of you doesn't understand it, probably several others don't as well, and I don't want to be confusing. So this is me. I have a private consultancy. I'm a sole proprietor. I work all by myself now. As Victor said, I've been in this industry a long time, and you guys have asked me to speak about geosynthetics and sustainability, and I'm happy to do so. But I warn everybody that my message is not necessarily superb. Hang on. Okay, so let's start with the caveats. My disclaimer. This is my opinion and my opinion only. This is not the opinion of the IGS. This is not the opinion of the Sustainability Committee. You're getting just what I think. And I have some reason to say that what I'm saying is reasonable. And I'm going to start with an apology. I am part of the population and community that has and actively continues to destroy our planet. The worst generation ever. Not all our generations are very good, but my generation has been fighting sustainability tooth and nail. And I'm ashamed of much of my past behavior. The example I give: over the course of my life, I have owned 18 automobiles. That's a horrific number. And I think in history, if the human species makes it in history, when we look back, people are going to look at the car and go, oh my God, what were they doing? So I'm trying to make up for that. And one of the things I have done is chaired the IGS Sustainability Committee. I learned a whole lot there, and I continue to be an active part of the committee, and I think they're doing good work. And I've been trying to improve my personal sustainability contributions. And most importantly for you, I've done the reading and I've done the math. So I have some things to say. The other caveat I'll give you that's not written down here is I don't want anybody to leave this feeling I'm telling you what to do. I'm not. I don't have that right to tell you what to do. But I'm asking, I'm pleading, I'm begging, because all of us, every individual person on the planet, needs to change our behavior if we're going to make it. So, as an experienced speaker, you always tell them what you're going to tell them. So the first third of the presentation is my concept of sustainability, and more importantly, where I got many of the opinions and pieces of information. I'm going to recommend to you a whole lot of reading. I read a lot of books, and that's an important place to get knowledge. The middle third of the presentation is probably something that many of you have seen before, but we should be proud of. Examples of how geosynthetics is making contributions to the sustainability of our planet. And when I say sustainability, an important caveat here, sustainability of the whole planet, not just the human race, everything and everybody on it. And then the last third of the presentation is how sustainability contributions are being measured, specifically for geosynthetics. And I think this is going to be new to almost everybody. So that's it. And I think that's a good thing. So I always start my presentations, or try to, with a quote from the Quran. And I won't read this. I assume you all can, if you're like me in foreign language, you can probably read and write the foreign language better than you speak it. But I start with a quote from the Quran because there's a certain type of American that reads the quote from the Quran and finds out that I'm quoting a language or a religious leader that is not popular in the United States. And they immediately freak out, and I want to identify those people so I don't have to talk to them further. But what's written in that quote there is very valuable. We need to propagate our knowledge and preserve it, and books are the way to do that. There's also a quote by H.G. Wells, a fictional writer, and this is absolutely true. Civilization is in a race between education and catastrophe. You'll see when I get to the United Nations Sustainable Development Goals, education is goal number 4. If people don't know what to do, then they're probably not going to do what they need to do. So it's an important thing. I'm going to talk a lot about truth, and truth is complicated, particularly in the current political environment. I use a few memes because I know that the younger generation communicates and speaks via memes, and I think most of them are very powerful for communicating ideas. And this is one of them. Truth is under assault in our current world, driven largely by our political leadership. But it's important to get to the truth, and the truth is complicated. It's not simple, it's not easy. Two opposing ideas can both be true. So that's something you need to be aware of. The other thing I'm going to tell you is that the test of a first-rate intelligence is to hold two opposing ideas. As I just mentioned, two things can be the opposite and both be true. And we have to, as intelligent human beings, we have to hold those ideas in our head and still function properly. So I'm going to talk about sustainability, but I can't talk about sustainability without talking about population. And this is a chart from the World in Data, a very good source of information. You see the web address listed on the right side in the box, ourworldindata.org. They're a very good source for numbers, unbiased numbers. And that's a good way to get at the truth, is to use numbers. So my point about sustainability here is that what is sustainable behavior for, let's say 3 billion people, which is how many people were on the earth about the time I was born. A sustainable behavior for that number of people is not a sustainable behavior for 7 billion, 8 billion, 9 billion, 12 billion. You know, we're on the edge of how many people the planet can sustain. Some will say we've gone already past the edge and we're just waiting for the catastrophe. I hope that that's not the case. But you have to consider how many people there are. The good news on this slide is that the growth rate of our population is declining. And I think this is excellent news. We need to be a little bit smaller. When our political leaders, particularly in the United States, Vice President J.D. Vance says we need more people, and you have journalists going to Japan bemoaning the fact that the Japanese population is so old and there's no young people. And I think both of those concerns are misplaced. We need less people. If we just continue to churn out people and breed, eventually, and maybe not too soon in the future, we're going to run out of resources and we're going to start killing each other again to get the resources that are available. And nobody wants that, particularly because we've gotten very efficient at killing each other. So I'm a population reduction proponent. But you, as I said, you can't have a discussion about sustainability without talking about how many people there are. Because there's a limited number of resources. This is what we got. And in olden days, we used to think that the Earth's bounty and resources were infinite. That's not the case. And we're using them up. And I have a personal example to give you. But before I get to that, before I get to my personal example, another chart from Our World and Data that says humans aren't particularly important. This is the construction of the planet by mass and weight. And plants obviously make up the greatest variety of that. But animals are just a small portion, and humans are a very, very small portion inside that sector. But we're screwing it up for everybody, which is not a good thing. So a modesty for the human species. Okay, so here's my personal story, and I have a couple slides to help me with it. And it's not about golf. The golf ball is there for scale. It's about the material below the golf ball called rounded river rock. When I first started in this industry about 30 years ago, I was given a job selling a geosynthetic that would replace rounded river rock. And I did very, very well. And it's obviously because I am singularly brilliant and intelligent. That's a joke, by the way. I hope you're all laughing. I am not that brilliant. But I did succeed very, very well at selling the material that replaced rounded river rock. We did a really, really good job. We had massive sales growth year on year. Here's a picture of the product. It's a geocomposite product, geonet laminated in between two geotextiles. And we were great at selling it. And we kept building new lines, et cetera, et cetera. The reason we were great at selling it is that rounded river rock was gone. The people in the United States had consumed all that they could consume that could easily and economically be gotten. The Earth takes centuries to make this rounded non-angular stone. And in a period of about 50 years, we scooped it all up and used it. And don't think that that's not continuing with other materials. The first book I would reference to you is called Sand Stories, The Surprising Truths About the Global Sand Crisis and the Quest for Sustainable Solutions in Sand. China has a fleet of ships that go out and mine sand from the ocean and islands and other beaches. We consume sand on a massive scale, so much so that we're using it up. And the price is going up and the availability is going down. And that's something else we need a sustainable solution for. And again, my point being, this is all we've got. This is all we've got to work with. This isn't a movie. We're not going to go draw an asteroid out of the sky that's going to solve all our problems, and Captain Marvel is not going to fly up there. These are the resources available to the human race at this time, and we need to be good stewards of them and use them appropriately. My other message to you is that we're all in this together. Here's another meme. I'm not sure which guy I am, but my point being, we're all in this together. If the Amazon doesn't make it, if China doesn't make it, if India doesn't make it, there is only one planet. Our political leaders are bending now towards us and them, and not liking people, again, with different skin color, different religious beliefs, etc., etc. And I'm here to tell you that none of that matters. We are all citizens of the planet, and we all need to act and behave together. Because if part of us doesn't work, the rest of us doesn't stand a chance. Okay, so back to my Allah quote and my book recommendations. I said I'd done the reading. I'm going to list off a bunch of books here. I hope you read all of them. I'm not optimistic that you will. I think there's 6 or 9 of them. It's a lot of reading. But if you only read one of them, you should read that first one called Thinking Fast and Slow by Daniel Kahneman, who recently passed away. It's a book about how humans think. And the way we think is very important. We're easily fooled. We like things in story form. And if things are in stories, if a fact is in a story and it fits within that story, we're very, very apt to believe it. And I'm going to give you an example right here. And I won't say anything for a minute, but show you this next slide. So I know English is not the native language, but hopefully you all reached out to the last sentence. And I would bet that 90% of you read this sentence. You will read this last fourth out of the 3 statements. We are easily led. And if you don't realize how you think, you're not going to be thinking efficiently, and people who sell everything, basically everything that gets advertised, are going to fool you. These other 2 books are about, again, much about human behavior. If Nietzsche were a Narwhal does a good job of explaining how we think as a group. I have 2 books on the list by Vlachal Smil. He's up in Manitoba. This one is called How the World Really Works. I'll speak more about him when I talk about the other one. So our crisis that we're in, so far as sustainability, has been foretold. If you want to read the prediction that occurred in the early 1970s, that is called Limits to Growth, Donnell Meadows. One of the other fallacies that were presented by politicians and economists is that we can grow our way out of problems. If we just continue to grow, all our problems will be solved economically, socially, etc. And that's just not true. There are limits to what we have, and they did a very, very good job of predicting the current situation we're in. So it's worth a read. Difficult book to get a hold of, but projects exactly where we are now and from the 1970s. The middle book there is called What Money Can't Buy: The Moral Limits of Markets. I used to open all my presentations with the commentary that I was a capitalist. I'm still a capitalist, but the problem is there are things that capitalism can't fix. I give an ethics lecture, and there's a long example about what a national park is worth. And the answer is it's priceless. You can't put a dollar value on it. And we're destroying things to make dollars that don't have dollar values. The book on the right, Robert Reich, The Common Good, is essentially a message that we're all in this together. Sapiens is probably the second book I would tell you to read. In some languages, it's called Humans, and it talks about our history. And my God, we are awful. Everywhere we go, everywhere we've lived, we just destroy things. And we need to stop doing that. If your particular interest is global warming, David Wallace Wells wrote a good book called The Uninhabitable Earth, where he talks about the effects of global warming. And probably my best book to people who don't like what I'm saying up to this point is the Vlachal Smil book, Numbers Don't Lie. And he tells us stories, but essentially they're not stories. Essentially they're equations. And I use this to justify a whole lot of what I say. You know, the bit with the population is easily figured out on the back of a piece of paper. You have X number of people. Each person needs X number of calories every day to live in food. It takes us so many hectares to grow that many calories. And you get to that and you find out, geez, we're on the edge of what we're doing. We've done a great job technologically of protecting and expanding our food base, but we're reaching the limits. So hopefully I haven't depressed you all, but there is good news. We have a plan. A goal without a plan is just a wish. Again, one of my favorite quotations. And if you read the mem on the right, it says essentially that same thing. You have to have a plan. I hope you're a believer in the United Nations, because our plan is the United Nations Sustainable Development Goals. We have a structure of what we need to do in order to maintain sustainable development. And it's written down and organized. And the good news is that geosynthetics, the industry that you're involved in, contributes directly to these. It starts with no poverty, which is probably the best goal. Somebody who's hungry and needs to feed his family is going to do things that are maybe not in his long-term best interest, but get food on his family's table the next day, which gets to hunger, health and well-being. But when you get down to number 6, clean water and sanitation, geosynthetics play a very strong role in that. And we continue to participate through affordable energy, infrastructure and industry, sustainable cities and developments. Responsible consumption and production is personal decisions we all make. But we've got a plan, and that's very good news. If we didn't have a plan, I'd be throwing my hands up. So I'm going to show you a whole bunch of pictures. We've reached the middle third now. I'm going to show you a whole bunch of pictures about geosynthetic contribution to sustainability, with some commentary on all of them. These are not all my photos. There's a list at the end of the presentation acknowledging photo credits. But one of the reasons I can feel decent about myself, despite the fact I've owned 18 automobiles, is that I've lucked out. I got lucky to work in an industry that makes an extremely valuable contribution to sustainability. And it starts with, the first slide is water storage. I show this slide because it's one of my favorites. I took it, which is good, but it shows the different layers of geosynthetics. And many people, even the people who use geosynthetics extensively for transportation, don't realize all the different layers that go into, for example, landfills or water storage. So I'm going to spend a couple extra seconds on this slide. Starting at the bottom left corner, you have your subgrade. That white sheet is a geosynthetic clay liner. It's used as a composite liner with the grayish sheet, which is your secondary liner. This has 2 liners. In between the 2 liners is the very black color, the geonet, that acts as a leak detection system. And then the primary liner is back in the background, the furthest one away next to the building that they're constructing, the industrial plant. So a lot of our stuff gets used together with it, and it does an extremely good job. But you need to be aware of these layers. We do a lot of water storage. This is a potable water storage reservoir. Water is becoming increasingly important. You can make the case it's probably the first resource that's going to go away, potable water. In some cases, the potable water reservoirs are covered with floating covers. This prevents transevaporation. Also, right after 9/11, there was this thing about contamination of the water supply, and it does protect against contamination, but its primary purpose is to hold on to water in arid climates. And this is probably the best and biggest example of that. Excuse me. This is an aerial picture of Palo Verde Electrical Generating Station near Phoenix, Arizona. What you see in the picture, those little blue boxes close to the middle of the picture, are nuclear power plants. Palo Verde is the only nuclear power plant in the entire world that is not located next to a river, a pond, an ocean, because nuclear power plants use a whole lot of water. This is a good one in that all of the wastewater from Phoenix, where there isn't a whole lot of water to begin with, all of the wastewater goes out to Palo Verde and is treated, and that's what the plant uses as their source of operating water. There are huge ponds out there. Again, for scale, you have a nuclear reactor in the blue building. You've got a total of 1.25 square kilometers of pond. All of this is lined with geosynthetic. That's how they hold on to the water in a geosynthetic environment. The geomembrane lines each of these various ponds. Some of them you see in the white are out of service or empty at the time, but we make a huge contribution there. I'm going to give you a couple of technical bon mots or little presents as we go through the presentation. The first one is that the geomembranes really work. Not only do they hold the liquid for the Palo Verde nuclear plant and many other facilities and landfills, but if you don't remove the subgrade gas from an area that you're covering with a landfill, or excuse me, an area you're covering with a geomembrane, the geomembrane inflates like a bubble. So while you don't want these, they are news that the geomembrane is really working. It's providing a barrier. The picture on the right is actually a canal in Florida, and those concrete protection retivents that are over the geomembrane are about 10 centimeters thick. So that's the geomembrane with gas pressure underneath lifting up 10 centimeters of concrete. So what you really want to do is vent that gas. That's one of my first technical gifts for you. Another application for geosynthetics is district heating. We used to do this a long time ago. We got away from it and need to get back to it. It's very efficient. If you have an industrial process that generates a lot of excess heat, that heat can be used to heat a city. Steam lines, etc. You can store the hot water in a geosynthetic line facility. And in some cases, you do this intentionally because it's more efficient to heat a giant storage area than heat each individual house. Another power and utility operation is the pumped water storage. This is a white geomembrane where they're pumping water during low demand periods of electricity. They're all connected to hydro plants. And what you do is when you don't need to use all the electricity you're generating, you use that electricity to pump water from downstream to upstream. That way, when you need more electricity, you can release the water from the reservoir. And most of them are designed to do this on a daily basis. Another short digression. If you don't want to read books, something that'll get you a lot of information is this YouTube video. The gentleman is Scott Tinker, the speaker. He was speaking for the Alliance of Responsible Citizenship. And I got hooked into the video because it said, have you ever seen a lithium mine? That was their hook to draw you in and get you to click on the video. And my answer to the question is, yes, I have seen a lithium mine. I've seen a bunch of them. This is a picture I took of one of them in China. I spent 3 years in China as a technical director for a geosynthetic manufacturer. And lithium mines are very, 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 very big. I'm standing in the middle of 4 ponds that are just like the ones you see here. So you're looking at one of the 4 ponds. You see this sign here. Pay attention to that sign because the next picture zooms in on the sign. And now you see the sign in a little more detail, but you also see back here power pylons. These are high tension power lines, and the distance between each of these power lines is about 1 kilometer apart. So you get the idea of how big these are. And what they are is gathering lithium for all the electrical cars we're building. I am not one who believes electrical cars are going to be a solution to our problem, because we spend a whole lot of effort, money, energy into gathering the lithium for the batteries and a whole other set of rare earth metals that go into the operation of these cars. And then when you get done with it, it's just again, another place that humans have gone and destroyed everything. So, but I'm trying to be positive in this section. So let's talk a little bit about landfills. I'm in Paris right now, and I was fortunate enough to live in Paris for several years. In Paris, occasionally the workers go on strike. And the workers that pick up the garbage went on strike for 2 days. And you could walk around the streets of Paris and see all sorts of scenes like this. So a couple pictures I took. All of our garbage, all of our waste has to go somewhere, and it goes into landfills. And these landfills are engineered facilities. They all use geosynthetics extensively. Here you see the construction of a facility. They're placing soil over the barrier system. And this is probably the biggest area where geosynthetics contribute to sustainable success. We couldn't live as humans if we couldn't isolate our waste and put it in landfills. This is a picture of a landfill in China. These are becoming ubiquitous around the world. They will be and should be everywhere. The other good news about this is, and this is just my personal position, in a short period of time, we'll be going into the landfills and mining them for all the things that are in there. Rare earth metals, thrown away computers, et cetera, et cetera. This is a picture of a canyon landfill. Some of them that are built in rural areas or rugged areas are canyon fills. Again, you see the scale here. Here's the ocean on the side. So these are big things. And they hold very dangerous things. This is a picture I took at the Oak Ridge National Laboratory. This is a new landfill cell that they're building that's going to contain low-level radioactive waste. We're working at night. Here's my second technical bon mot. We're working at night because we don't want wrinkles to be present in this geomembrane. You've seen some of the pictures that have had a wrinkly geomembrane. The better, less leaking geomembranes have no wrinkles. And this is just thermal expansion and contraction. So if you work at night, when the sun's not out, it's easy to keep them flat. But some of the nastiest things that humans create in terms of radioactive materials can be stored in geosynthetic line facilities. Here's a mining facility. I'm going to talk about tailings dams in a little bit, but this is actually water storage. But I would bet eventually it's going to turn into a tailings dam. But it's mining is an area where geosynthetics are extensively used. Dredging dewatering, where you can use a geosynthetic three-dimensional structural container and dewater materials, remove sludge from the ground, or excuse me, remove sludge from the river and actually create ground. Here you see a picture of a bunch of dewatering batteries. Used in erosion control. This is a picture of a concrete impregnated geomembrane used to prevent this planned creek from eroding. Here's the same sort of application except on a much different scale. These large walls here are manufactured with geogrid, and you have the gabions above it. Apparently in the spring, this water turns into a raging torrent, not the calm river you see, and they're protecting whatever's on the upside slope of this. We do a lot of this type of protection around our coastal areas. Here you see a combination of the sand-filled bags. Some vendors call them geotubes, which is a good description. And then you have the revemented protection for coastal erosion up here. The tides are protected by the geobags. And then high wave action, typhoon, hurricane activity up here. They used a lot in canals. It's necessary to build canals to get the water to arable acreage where we can build the food that we all need that I talked about before. Some of the largest canals are in Egypt. There's a variety of designs for them. Some use concrete, some do not. Some just use the geomembrane and soil. But these are an important place where We have learned how to move water around efficiently and economically, and again, in a reasonable, responsible fashion. Plastics in the ocean are a problem, and we are plastic material. So we're part of that plastic problem. You know, my statement on that is that there's a huge difference between a technical geotextile that you'll put under a bridge that'll last 100 years and still be there after that, and a single-use plastic bag that somebody mistakenly throws away and gets swept out into the ocean. It's just a huge problem. We're polluting our oceans in an unsatisfactory and unsustainable manner. You see down here in the bottom right of the slide, I've written the word microplastics, but I don't want to waste your time talking about microplastics, because it's not microplastics, it's macroplastics. You know, it's jugs, cigarette butts, all this stuff. Good news, geosynthetics. This is a geonet that's actually attached to an end of several sewage system drainage tubes, so we're making a contribution there as well. Oh, sorry, there we go. A couple more bon mots. One about barrier integrity surveys. I mentioned that these geomembrane barriers are working well. One of the ways you do that is you conduct an electrical leak location survey over the material after you've put the soil on top of it. So you know by putting the soil on top of it, you haven't hurt the barrier system. I'm not going to explain how this works, but it's fairly straightforward technology. And you can detect holes in the geomembrane that are very, very small, even through a meter or so of soil. So it's a valuable technology, and if you don't want your barrier system to leak, you should use it. The other technical bon mot you need to be aware of is interface friction. All of these geosynthetic materials have friction angles. If you build them on a slope that's too steep, the material you put on top is not going to stay there. On the drainage side, you need to keep that drainage from being saturated, but you have to use proper design. So that's something technical you should pay attention to, because what you see on the screen in front of you is not long-term sustainable behavior. I would be remiss if I talked about sustainability and didn't mention tailings dams. My apologies to you and your country. This is a picture of a Vail site where they had a failure in January, and they had a tailings dam that slid and killed a bunch of people. Tailings dams are a nasty little secret of the mining industry, and it's not so much a secret anymore because we have regular tailings dams failures on a sustained basis. There's a gentleman named C-Mac Paulson, an engineer out of Australia, who actually puts out a newsletter where he tracks all this. I've said a couple bad things about lithium mines. Essentially, all mines, in my experience, there's a tendency for the mine to be under-designed and under-engineered, which is how these tailings dams fail. Most of these are not engineered properly, where they started piling up stuff. If you use a geosynthetic, it probably won't fail. That's not so much the result of the geosynthetic as it is of using proper engineering. But several of them are failing because even after you use proper engineering, in a quest for money and profit, people are overfilling their tailings dams, and they're just not stable, and eventually they fail. As a species, we can't continue this to happen. We need to do a better job of mining cleaner and returning the land to what it looked like before we took the things we wanted out of the subgrade underneath. So, Boyd says that geosynthetics are part of the solution. Is that true? Should you necessarily believe me? Well, I've mentioned numbers several times, so let's use our numbers, shall we? Lord Kelvin said it first: if you can't measure it, you can't improve it. Peter Drucker popularized this in a business book: if you can't measure it, you can't manage it. So we need to measure the sustainability contributions of geosynthetics. And the good news is we're quite far along on this. There are ISO standards for all of these protocols for things called environmental product declarations, which I'll get to in just a second. But there are ISO standards that everyone around the world should be using for things like life cycle assessment and reporting greenhouse gas emissions. And the standards are here. You can get a copy of the presentations. But the first thing is we have to all be doing it the same way. And the good news, there's a methodology for us to do it. The result of this is, for most products, something called an EPD, or Environmental Product Declaration. And an Environmental Product Declaration is exactly that. It declares what is used and the environmental impact of making a particular product, where the raw materials come from, how they're processed, how much electricity is used, how much waste is generated, and it's in extreme detail. So most of the geosynthetic manufacturers at this date are publishing EPDs, and EPDs are an important part of how you evaluate the total lifespan of the contribution of a material. And here's where I'm contrasting the electric car with the geosynthetic. In the electric car, once you get it to the car part, it's really efficient and really non-CO2 emitting. But making the car is a horrific process that utilizes tons of really expensive and dirty materials. So you have to look at that whole picture. And the same thing with geosynthetics. You have to go from how we make it to how it's used to then how it's taken out. So this isn't an IGS presentation, but I'm reporting on some of the actions that the IGS has done. They selected a program called One-Click LCA that globally provides a methodology for doing this life cycle analysis. They bought a multi-user license. They engaged teams, one from George Mason University and one from Barcelona, to prepare example templates. Our industry has a lot of good examples of how geosynthetics are used in sustainable behavior, but they're old and their methodology of compiling them is not necessarily identical or current. So we wanted to use this new methodology that's current, ISO-driven, EPD-driven. So we had these two university groups prepare templates. They launched the calculator in Rome. Any IGS member can use it. We're promoting it, and it's going to be a part of the IGS handbook, which should be coming out soon. This is from the group in Rome. Annabelle and Ivan are making very, very good contributions to sustainability. They're both on the sustainability committee with me. And they did an analysis. This is from a paper that they published back in 2017. Which is a comparison of different ways of constructing a retaining wall. And it's a very good presentation for its time, but it's not current. It's not using the best available technology. So One-Click LCA has an analysis that goes through a bunch of stages, and this is all documented by the ISO protocols. For the raw material, that's the raw material that makes the geosynthetic, how long it takes and how difficult it is to get it to the manufacturing site where we're going to make the textile or the grid or the geomembrane, how it's manufactured, how much electricity is used, waste is generated, how that gets transported to the construction site where it's actually going to be used, how much installation and assembly is put into installing the material. The B series is how it's used. This is not so much relevant for geotechnical structures, except where you have to go in and repair them. And then the C stages are the end of life. What do you do with it when it's all over? The good news is most geosynthetics materials are made to be used for a long time. But my point to you is that this analysis that I'm about to show you is cradle to grave, from the very basic raw materials, oil, where we get the plastic from, to the end of life of the geomembrane or the geonet or whatever it is. And these are some of the protocols we use. I think I'm time sensitive, so I'm going to go a little faster. The calculation variables are complex. This is not something where you can scratch it out on the back of a notepad. You're looking at how much waste is generated when you make these materials, how far they go. Do they travel by truck or by boat or by train? The EPD draws a whole bunch of information that's used. This is a technical comparison that's worthy of the evaluation and the time you take to put in to get this evaluation. So here's what you see if you go to the one-click screen. These are 6 of the 9 or 10 examples we have, and they cover all the geosynthetic applications, landfill lining, canal lining, road construction, retaining wall construction. It's quite a broad-ranging tool. It can be used for almost anything. These are what the results look like. I'm going to go back to my example that I talked about with the golf ball and the rounded rock. This is a comparison of doing a gravel drain versus a geosynthetic drain. So this is rounded rock or rounded river rock versus a geocomposite product. And you see some of the products here. There's a nice set of videos on YouTube at the IGS Sustainability channel that explain this and how it's used. I'm just going to show you some of the highlights. You talk about how much material you use. Each of those materials per unit area has a certain CO2 emission, and it's drawing this off of the EPDs. Each of these is specific to a specific environmental product declaration a manufacturer has made. The classification of the material, how far it's transported is an important variable, and you can set up 1 or more legs for transport. The next slide goes out to the right, talks about service life, how long the material is going to last, how long its lifespan is going to be, how much wastage you're going to have in terms of installing it, if there's going to be any repair process, whether it's a plastic-based material or you landfill it at the end of life process. It's really thorough, and again, draws on these EPDs for background information on the materials that are used. And in this case, you see a bunch of numbers here. I'm going to go through some screens showing the results. The good news, the thing that you should feel good about in terms of CO2 emissions in any case, and you can do this for CO2 and water and power usage, but in terms of CO2 usage, the blue bar there is the gravel drain, and the yellow bar there is the geosynthetic drain, which emits probably about 1/3 of the CO2 of doing this design with the traditional gravel materials versus the geosynthetics. And all of them have this sort of result. When you look at it, you find that the geosynthetic is 10% or 15% or some dramatic difference between the traditional construction method, especially in terms of CO2 reduction. You can slice this data 8 ways from Sunday. This is that same data, but now it's being presented going through the lifespan. This blue bar is the raw materials, and then you have the transport in orange. It takes a lot of trucks to move this gravel around, so their transport contribution is huge. Energy consumption. So there's a great deal of information on how you want to evaluate it. This is global warming in terms of CO2 for the various materials. This is the same thing showing through the lifespan. And again, sorry, this one's for fuel, showing fuel consumption. But my point being, there's a whole bunch of different ways to evaluate this. And this is what you should be doing if you want to say, my product, my material, my site, my construction is sustainable. And again, there's a whole bunch of different cases that you can look at. So this is available free of charge to IGS members. You can look at the templates. You can play with the templates a little bit. This operates within one-click LCA. User training is necessary. This is not something that you're going to just jump in and pick up immediately. I am not as software enhanced as most of the young people are these days. Took me about 6 hours to get this to where I could do what I wanted with it. Somebody who's more familiar and has been using computers since their birth could probably do it in 3 or 4 hours, or maybe less. But the most important thing is that this provides a measurement of geosynthetic benefits using current best practices. You're using ISO, you're using standardized practices. And in every case, when you do this analysis, you find out that geosynthetics are more sustainable. So what do I want you to do? And again, I can't tell you what to do. I'm asking you to think. First, think about how you think, and read and act. I'm just one guy. There's a big planet. But I firmly believe the next 2 quotes I'm going to show you. A man who removes a mountain starts by carrying away small stones. The small little actions that all of us do on a daily basis add up to something, because there's billions of us. So it's important. And I also believe that nobody made a greater mistake than he or she who did nothing because he or she could only do a little. Again, there's billions of us. What each of us does, it may seem like it doesn't matter, but it actually does. So what can you do? You can make wise and informed consumer choices. You can use proper transport, proper packaging, eliminate single-use items, use more public transportation, less automobiles, don't fly. I try not to fly at all. I've flown once in the last 2 years. Not that I'm a saint. Again, I've got a lot of back poor sustainable behavior to pay for. Use less automobiles. Again, you don't own 18 cars. I'm ashamed of that. But that's one of the big drivers. Transport is a big sustainability contributor and resource consumer. Recycle, recycle, recycle. Think before breeding children. God, I beg you, please, not more than 2. We just can't sustain that any more people. Engineer and design with sustainability in the forefront of decision making, because whether something is sustainable or not is important, but we have to measure it. We have to quantify it. You have to give economic factors proper consideration, but they're not the only consideration. The economics and sustainability, one of the big problems we have is the disconnect between economics and environmentalism. People are allowed to walk away from things like tailings dams, things like gypsum stacks, because the company declared bankruptcy and there's nothing we can do with it. That sort of behavior needs to stop. But I'll hop off my soapbox since I'm down here at the end. Some acknowledgments, some photo credits. Again, this is not an IGS endorsed position. This is just me talking. But I was allowed to use many of the photos from the young members, the ASICS chapter, and some of the organizations in our industry, as well as some individuals that I'm proud to have worked with over the years. So this is me, and that's the end. And I'm happy to take questions or talk for a little while at least. It's getting close to midnight here in Paris, so I don't want to talk forever, but certainly for 20, 30 minutes, I'll be happy to entertain your questions. Thank you very much.
Thank you, Boyd. So nice. Thank you so much for this brilliant presentation. I'm thinking how difficult some of the recommendations you make they are for us to implement in our daily lives. Others are much more possible, some of them, but for sure everything you've presented make us think on how selfish we are and how we can do the same things that we've been doing for a long time in a different way. And that, I think, it applies also to how you build and how you build with the same materials that our industry is used to build, like steel, cement, plastic, and so on. So I think there is a way of doing things differently.
Yeah, geosynthetics are a win. We use less resources. We're cleaner. We last longer. It's a really good product. And back to your first comment, Victor, it's not an all or nothing thing. I'm not saying that you're a bad person if you don't want to go live in a cave and eat celery. But here's the example I give. I was, and again, I'm not brilliant, but I just got lucky in this case. One of the first big oil spills was called the Exxon Valdez. Happened off the coast of Alaska. The captain was drunk. He drove his ship into the coast and spilled oil all over the ocean. I was about 9 years old. The next day, my dad went to buy gas for the car, and he pulled into the Exxon station. And I was just incensed. I was like, "Dad, what are you doing?" And if everybody had stopped pulling into the Exxon station the next day, we never would have had another oil spill. It just wouldn't have happened.
Sure.
So all of our individual components make a contribution. And again, it's not all or nothing. I don't expect leaving this that, people are going to stop flying.
Of course.
But
you don't need to have 18 cars, but perhaps 8 is enough.
I feel bad about that. I feel awful.
No, but I think the like you said, there's one thing that makes you feel better about this is like knowing that looking behind and looking forward, you've invested a lot of your time and knowledge working with the technology that we can finally calculate and define a common variable to compare with other technologies and see, look, we are investing time on understanding a technology and applying a technology that is really sustainable.
I got lucky.
Yeah. You didn't know what you're doing, but finally you found an excuse now.
Yeah, I got lucky and got put on a good path. Something I didn't mention in my presentation that I think is a really good sign. We gave a seminar in the Netherlands. And in the Netherlands, they have a system for evaluating public works projects.
Okay.
And the environmental contribution and sustainability contribution is a part of that. And it's valued at 20% of the total decision process. So in other words, if you're building a bridge and the bridge costs a little bit more, but you can build it and it lasts longer, has more sustainable contributions, lower maintenance costs, et cetera, et cetera, you can build the bridge that costs more because it's a better bridge. It's that's something that I'm really happy with and trying to promote.
I watched your presentation on that seminar, and I remember that someone, I don't know if they were from the Netherlands government, I remember they mentioned that, and that made me really positive about the future. And what you just said has everything to do with a question that just came in by someone you might know, Professor Enio Palmeira.
I'm honored.
He's here watching us, and his question is, well, first he says, "Dear Boyd, congratulations on an excellent presentation. Just a question. When, if ever, do you believe sustainable engineering solutions will become mandatory rather than simply desirable?" So I think it's what he was just saying, right?
Yeah, and Professor Palmeira, thank you for giving me an hour of your time. I appreciate it, particularly coming from you. As this goes back to my slide on a race between education and catastrophe. If I had my way, we would start doing this tomorrow. And if we start doing it soon enough, we won't have these big wars over, water, resources, rare earth metals, et cetera, that are, I don't want to say they're just around the corner, but when you look, you can see them, and it's a very bad thing. But the thing that we need to do is the thing that I described in the last third of the presentation. These have to be ISO standards that are quantified, that are measurable, that are verifiable, I didn't mention this about the EPDs, but the EPDs all require an independent inspection and verification of what the companies are putting out. You got to do it that way. Otherwise, it's just, hey, my stuff's better.
Yeah. You have to take out that miracle part of the geosynthetic, right? Like that we've used so much along the time, like the geosynthetic solves everything, and we show the data sheet and say, oh, my product better than yours. Let's talk about real.
Yeah, you got to prove it. You got to prove it with numbers and ISO protocols, and it can be done, and the IGS is helping to do it.
Boy, to your point about reading, and I love the books that you've indicated. If you let me, I can share this with all the audience later with just writing down the name of the books that you mentioned. I think
sure
perhaps people didn't have a chance to note down all the details. But there's one book I read recently. I don't know if you've read or if you agree with it or not, but it called me attention on the way, in the sense that, and the book is How to Prevent a Climate Disaster. It was written by Bill Gates, and reading that book, he presents a concept of green premium for construction technologies. And this concept talks about how much an industry, let's say the steel industry or the cement industry or the plastic industry, still have to invest to make that technology zero emission. And he makes a comparison among those three specific materials: steel, cement, and plastic. And it was really interesting to see that, and he shows some numbers of how much CO2 is emitted when you produce 1 ton of cement, 1 ton of steel, and 1 ton of plastic. And the numbers are amazing, because plastic is less than 1/3 of the cement, less than half of the steel. And he says that plastic, because it embodies the CO2 during the whole life cycle of the product. So if you have a long-lasting plastic, it was like he was talking about geosynthetic, but I'm sure he doesn't know about it. I don't know. I'm not sure, but he might not know geosynthetic in detail, but he was saying that perhaps plastic will kind of, because of this, replace or be responsible for replacing part of the applications of cement and steel. So I wanted to hear your opinion around that, because geosynthetics, they can be applied on really innovative and sustainable applications like you showed, but they can also be applied in common applications to replace common materials, like we do with sand, like we do with earthen materials. We can replace steel, we can replace cement, or we can enhance that or diminish the use. So what is your opinion about that?
I think you're absolutely correct. There are things we're not going to get away from using those materials. We need them, but they are no longer the most efficient material for, let's take the example of a retaining wall. The only place you really need concrete on a retaining wall is for the surface face. All of the other materials can be accomplished with geogrids, with high strength geotextiles, and it builds a better wall that's cheaper, that goes in faster, that has less CO2 emissions. It's concrete is a mess. Excuse me. If you read that book I referenced about the sand, that's where all the sand is going. It's going into concrete. The concrete uses 80-90% of the sand that we're taking out of the places where the earth has put it.
Oh, that's interesting.
Yeah. That's
a huge number.
Yeah. And concrete is a mess.
like there is another, like in Brazil. In Brazil, we have Latin America as a whole, I think, but in Brazil, we have a lot of like walls, soil nailing walls in cut situations that we do a lot of shotcreting, and shotcrete, they are horrible, right? Like they don't look nice. They are like a scar in the middle of, and we are a tropical country, so sometimes you see that beautiful landscape with a huge, shotcrete in the middle of it. And today there are green soil nailing, right? You can use the concrete in the nails, you can use the steel in the nails. Of course, we won't replace that, have other technologies, but they are okay there because we don't use so much in nails and but in the facing we can use geosynthetics, geomats, and things like hydromats to make it green. So I think there are a lot of opportunities for geosynthetics to replace these materials. And
absolutely, we've got a really good story to tell.
There's another question here, Boyd,
yes.
by Professor Portelinha, Fernando Portelinha, from the Federal University of São Carlos. Hi, Boyd. Thanks for the presentation. And he asks, how has it been to separate sustainability from costs in the US? I think that applies to other markets also, right? But what has the market been willing to pay for sustainability? And how challenging has this been?
Well, first off, hi. I've interacted with Professor Portolina before with my IGS Foundation hat on, so happy to see you, and thanks for being here. Okay, I didn't address this in the presentation, so I'm going to try and address it very simply now. Our problem as a species is we've allowed the economic costs to get separated from the total costs.
Yeah.
And I'll use a personal example from my life, gypsum stacks. When you make fertilizer, which is necessary for growing plants, the side product of that is a chemical called phosgypsum. And you can put it in wall boards, but it's really not good for very much. In Florida, there are about 100 hectares of phosgypsum waste that have been piled up, and the owner didn't make economical plans for what to do with it, and in fact probably never intended to do anything with it. And then the owner declared bankruptcy and said, "Oh, I'm sorry, we've taken all the money out of the company, we're no longer profitable, we're bankrupt." Well, what about this giant pile of phosgypsum you've left there? And you can extend this to all sorts of, you can extend it to tailings dams. We do it as a species now with things like tires and refrigerators. You can't just throw away a tire. When you change the tire on your car, you're charged a small surcharge because it takes money and effort and energy and things to get rid of the tire, or a refrigerator, or whatever appliance you're trying to throw away. But when you go buy tires, in some countries you're charged for this, but in some countries you're not. So our economic system is failing us because the price of a thing in many cases doesn't represent the true cost of that thing over its lifespan. Okay, I'm going to pound on cigarettes. Cigarettes are another good example. The health costs of cigarettes are huge, but has anybody calculated the costs of all those little filters that people throw out into the street? Those filters go out into the waste system. They get put in your wastewater treatment system. They have, the true costs, and then maybe the cigarette thing is a bad example, but the true costs of things and their economic costs aren't really as well connected as they should be. The sustainability component of it isn't there, and it needs to be.
Nice way of thinking. There's one phrase that you mentioned: capitalism can't fix everything. And I think us taking part of a an industry that I think most of the people here that are watching, and nearly all the people that work with geosynthetics, I think we are kind of capitalists, right? Because we sell goods and we specify, and we are involved in this way of living and making business and so on. And one thing that worries me about, and I'm sure I'm a capitalist also, but one thing that really worries me about capitalism is that money tends to accelerate things and accelerate decisions, and accelerates decisions overseas also, because money travels much faster than other things. You wire transfer money and take a decision on the other side of the planet like this. So when you don't have like laws or regulations put in place that will try to orientate these decisions that money make, I think that's when the danger about capitalism occurs. And one thing that made me positive about like the Paris Agreement is that the Paris Agreement joined 196 nations at the time, and they all came into an agreement that, of course, was part of it political, part of it was social, part of it was financial, and in average, all these nations together, they define goals, and we are trying to go after those goals, of course. And I'm sure that we won't achieve those goals as we planned, in the same speed and velocity that we planned, the reductions of CO2. But the fact that everyone took the decision together, and that decision is not only financial and is social also and political, that makes me a bit more positive about the way we are drilling our paths on reduction of CO2. In that regard, Boyd, I know there is a country among those 196 countries that you know well that have recently decided to just, ignore that agreement. And I'm not talking about politics here. I'm just talking, knowing the American market and knowing the American economy. If you think that decision can really be impactful on the delay for the other countries achieving the goals they have set in the Paris Agreement.
Well, multiple parts to my answer. The first part is, there's a few countries that have more impact because they have more people. China, India, Indonesia, U.S., Brazil. There's a reason there's a G8 meeting and a G20 meeting, and that matters. The bigger answer to this is we're all in this. We have to recognize we're all in this together. And that lesson is going to get played out. There's where the current thing we spent the last 3 weeks talking about tariffs, but there's a guy named Thomas Friedman who wrote a book about how interconnected our world is. There are very few things that are made in one place from one thing that is there. Many things in the developed world are, it's cheaper to do that part of the construction in this country, and then we move those materials over and we do this other part of the construction in this other country. And our leaders have to recognize that we're all interconnected. And as far as the activities of the United States, my meaningful response to that would be, there's a reason I live in France.
Okay, boy. Okay. There is a question here from our friend Julio Zambrano from TRI Brazil. Julio works with Sam in TRI. Do you know of monetary incentives for companies to apply sustainable actions and having the sustainability calculator as a tool for it or other tools?
Not on the strictly commercial side. Where we are right now in most countries is for public works projects, things that are paid for with government money. You have to have things like environmental impact statements, et cetera, and those are drawing more and more to sustainability. So it's happening on the public side. It needs to happen. I haven't talked much about acceleration, but we need to accelerate that onto the private side where, if you want a permit to build a factory, you can't just build the most economical factory. You have to build the most sustainable factory. Mm-hmm. And then there's a chicken and an egg thing here. You need the ISO protocols and the standardized methodologies if you're going to make people make business decisions based on these factors. But my message to you now is we have them. We just need to use them and propagate them and get the regulators and the governments to require it.
Yeah, I think there are some questions that came in the same direction, and it's something that I was going to ask if they didn't ask, and I would rephrase that as, when is geosynthetics really getting the credit for the carbon credit it generates, And because when we use the calculator as you just showed, and I have done that myself, and I compare like a concrete retaining wall compared with an MSC wall with GeoGrid, I've come into a number that we can reduce the emission of 1 ton of CO2 equivalent per square meter of wall, something around that.
Yep.
When you consider everything. And when we look, now thinking on the financial side of things, and that's where I think we want to see that credit really accelerate in that sense. When we see the value of one carbon credit around the world in the different markets that are already regulated, you can get to $100 per carbon credit. Like if you look at the stock market for carbon credit in Europe, it's around $100 per ton of CO2 emitted. And if we make a direct relation of, if we save 1 ton of carbon credit per square meter of wall, and in Europe it values $100 per carbon credit, when is this gonna come true? We'll be able to use those numbers in favor of the technology when we compare to others. I know this is very naive.
Yeah.
It's very naive.
No, it's not naive.
It's not going to happen in the short term, but these numbers, they really impress.
Yeah, and that's what we need to do. And it needs to be the same in Brazil and Europe and Australia and India. Not exactly the same, but not completely different either. And okay, I've given recommendations for a bunch of books. I'll throw in one more. The last book I read is called Factfulness, and I can't remember the author's name, but that's a much more positive book. And he talks about this. He talks about how fast we're changing things. The idea of marrying carbon credits to emissions. That's not. That whole idea is probably only 20 years old, 25, maybe 30. And already we're moving forward with it on a very fast basis. We need to move faster. Mother Earth is moving at her own pace, and we don't know when she's gonna do something particularly violent. And then quicker is always better. But we are moving in the right direction, and we just need to get everybody on board the boat that we're all in and get there as quick as we can.
I think there's one thing that has happened with like with the Paris Agreement and everything that came after that, and is that we've created a common variable for everyone to look at. That is the CO2 equivalent.
Yes.
And so the CO2 equivalent, it's a new variable that everyone is getting used to it, right? When you buy a air ticket, for instance, you pay for the luggage, you pay for your seat. And do you want to make it zero emission? Okay, can you pay for like $20? So everyone is putting their own, is having their own contact with the real value, money-wise, of CO2 equivalent. So when people, I think it's my opinion, when people get used to this common variable, they will be able to compare the potential of sustainability among different things, and then I think when this happens, geosynthetics will be in a really good position, because the numbers you show and the numbers that the papers that are being recently published, they show that we are 90%. There has a 90% potential of reducing CO2.
All of those analyses, every case, the geosynthetics are not, and I'm not talking a little bit better, way better.
It's way better. Yeah. Okay, boy, that was such a nice talk. Let me give you a final message here that comes from our president, the president of IGS Brazil, Professor Maria das Graças Gardoni. She's watching us here, and she has sent you 2 messages. One says that IGS Brazil thanks you for taking the time to present us with this excellent lecture. Congratulations. IGS Brazil currently has a sustainability committee that has been working hard on this proposal. And she also says that IGS Brazil would like to thank the IGS Foundation, because you've been very active here, helping us on investing in education and together with IGS Brazil. So through you and the past president, for all the financial support it has provided for courses and symposia. This is the message from our president.
Thank you very much, Maria. And I would thank the donors to the IGS Foundation who've made that possible. And also Maria for her contributions to the particularly, she's made a bunch of contributions, but particularly the digitization of the Educate the Educator content. For all the things we're talking about, if we teach the professors and they teach the students, we're going to get there quicker. And she made a very important contribution to that.
I think IGS Brazil is the chapter that most organized the ETE programs around the world.
Yeah, you guys are leaders in that.
I think it's 6 editions, and we in Brazil, I must say, boy, and I know that everyone agrees with me here that there is a responsible for that, and that's Professor Gardoni, because she's really, she really loves this program, and she's so excited about doing it every year, and we're going to have another one this year. It's the 7th edition. So
you guys are fortunate to have her. She's a great lady.
Perfect. So Boyd, Thank you so much for your time. I know it's very late where you are.
That's okay. I'm going back to bed.
Everyone here, no one is worried with you that much because you're in Paris. So a lot of people would want to be in Paris. It is a nice place. So
it is nice.
You.
Good to be here. And spring in the Northern Hemisphere. So we like that part too.
But I'm joking. I know it's a great effort for you to be here at this time, and hope to see you personally soon. And you're always welcome to Brazil. I'm just going to finish in Portuguese here, okay? But
go ahead. Again, I'll just hang on.
Ok, thank you very much, Boyd. Bom, pessoal, então chegamos ao fim de mais um webinar da IGS Brasil, em parceria com o canal Geotecnia Brasil. Eu queria deixar os agradecimentos mais uma vez pelo convite a mim e ao Boyd para a IGS Brasil, para o canal Geotecnia Brasil, especialmente para o Comitê de Sustentabilidade da IGS Brasil, na pessoa da Emília, que está fazendo um trabalho magnífico aqui no Brasil. Convido a todos os sócios e não sócios a conhecer o Comitê de Sustentabilidade da IGS Brasil, entrar em contato com a Emília. Ela está fazendo um trabalho realmente... Na verdade, era para ela estar aqui hoje, ela teve um imprevisto pessoal, não pôde participar, espero que esteja tudo bem. E, por fim, queria dar uma notícia de primeira mão. Oh, boy, I have a news for you also. I'm going to translate it later. I'm saying Portuguese first and then... uma notícia em primeira mão que chegou hoje, né? Hoje nós recebemos a confirmação, a aprovação do comitê da ISO TC 221, que vai ter a sua reunião anual aqui no Brasil. Isso é uma grande alegria para a gente, geossintéticos. Para quem não sabe, o TC 221 é o comitê da ISO que trata dos geossintéticos e tem reuniões itinerantes no mundo inteiro. E dessa vez a gente conseguiu trazer para o Brasil, era um desejo do comitê, né, pelo reconhecimento do trabalho que a IGS Brasil, as associações afins, a BINT, né, toda a comunidade de geossintéticos vem fazendo e que vem trazendo resultado e aparecendo para o mundo, né? Então, essa reunião vai ser em novembro, provavelmente entre os dias 18 e 20, em local a ser definido ainda. A gente vai informar a todos, e a IGS Brasil, obviamente, já declarou apoio e faz parte da comissão organizadora desse evento, dessa reunião desde o princípio. Então, Boyd, just to say that today we've received the confirmation from TC 221 that the next annual meeting will be in Brazil next November. This just arrived. It's a very recent news.
Oh, good. Congratulations.
Yes, it will be in Brazil. We still, it's so new that we don't even know in what city it will be because we just received the confirmation, but the date will be around 18 to 20 of November. Okay, so we'll keep you posted and updated on that. And perhaps it would be really nice to have you in person here in Brazil in this opportunity.
Well, thank you for the invitation.
Ok. Bom, pessoal, boa noite a todos. Muito obrigado pela presença de todos e até a próxima. Obrigado.